Tonight, second video is the second lesson of Unit 14, Lesson 14.2 on cube roots. And we're going to again find cube roots. We're going to evaluate expressions. And our central question, how is the cube root of a number different from the square root of a number? So, ladies and gentlemen, there's a couple things we need to talk about on that. Hopefully you took some notes from the top of page 634 on cube roots. And that you know cube roots means what number do I multiply by itself 3 times? 3 times to get that radicand, and that would be the cube root. So a couple things to talk about here. One, we know that when we're talking square root of a number, that means some x times x, some number multiplied by itself 2 times. Even though nowhere in there does it say second root, it is understood in general mathematical terms always that if it's just the radical sign, it is the square root. But now we're doing cube roots, which means we want another root, and roots use radical signs. But we want something different than square, so we're going to put a different number in there. So we have the cube root, so that 3, the root that you want, goes inside the check mark of the radical sign, and then what number is multiplied by itself 3 times to get that number, right? To get that number. We could have the 7th root of some number. In other words, x times x times x times x times x times x times x to equal that number. And if we wanted the 7th root, we would put the 7 in the radical sign and say how many times do we, 7 times multiplying a number to get the radicand. All right? We also recognize that square roots can only be positive numbers, right? Because we know that a positive times a positive is a positive, and a negative times a negative is also a positive. So there is no possible way that we can have the square root of a negative number. This does not exist. However, we can have the cube root of a negative number, because a negative times a negative times a negative does equal a negative. So we have to understand that those are important things that going down the road. All right, so let's just get busy and talk about finding some cube roots. I want to back you up just a second. I'm sorry. Well, let's go right here again. There are some cube roots that you should have memorized. So let's get to those right away before we get started on doing the examples. That's the first 5 you should have. In other words, 1 cubed is 1. In other words, the cube root of 1 is 1. And 2 cubed is 8. And so the cube root of 8 is 2. And 3 cubed is 27. So the cube root of 27 is 3. And 4 cubed is 64. So the cube root of 64 better be 4. And the 5 cubed is 125. So the cube root of 125 is 5. Those are the ones you should have memorized at this point. You will need and probably find it useful to memorize more later, but for right now, those are the case. So going right to our example number 10 today, if we have the cube root of 8, we recognize, well, I'm supposed to have that memorized, so that answer is 2. And notice there's a plus sign in front of the 8, so it is that positive cube root. All righty. Now we have the cube root of a negative 27. We said, hey, you can take the negative number. We know the cube root of 27, we just wrote it down in our chart. The cube root of 27 is 3. And we know that negative 3 times negative 3 times negative 3 is negative 27. So the cube root of a negative 27 must be negative 3. Now we have the negative cube root of 125 over 343. So we find that the answer will be negative because there's a negative on the outside. The cube root of 125 just happens to be 5. We had that memorized. But you'll probably have to use your calculator because the cube root of 343, well, that is 7. So a negative 5/7. Now I'm going to throw a little wrinkle at you. It's not in your notes, not on your insert, but I just want you to think about it. Could I have the negative cube root of a negative 27? Could I? Sure. We just did the cube root of negative 27 and said it was negative 3. But now we have a negative on the outside. So if I have the negative cube root of a negative 27, well, negative and a negative, this would end up as being positive 3. Just to throw a wrinkle at you So you might see that. All right. Evaluating some expressions. Once again, it's just following the order of operations. So 3 times the cube root of 125 minus 8. And remember, that radical sign is a grouping symbol. So we must find the cube root of 125. Well, we have that memorized. So this is 3 times 5. Oh, excuse me. 3 times 5 minus 8. And when we do the order of operations, that becomes 15 minus 8, which is 7. Just going to do a couple straightforward ones with you so we can keep our time down, moving right along. You should be proficient at order of operations, and the only different thing we're throwing in there now is these cube roots. So now we're taking the cube root of 27, and we're cubing that answer and subtracting 4. All right? So one thing you should think about. If I take the cube root of any number cubed, well, that's the number. And if I take and cube any number after I've taken its cube root, well, that's also going to be the number, right? Those are the inverse of each other. So right here, if I take the cube root of 27, that would be 3. And then 3 cubed minus 4, well, that's 27 minus 4. So the cube, taking the cube of the cube root of 27 does give us 27. And of course, that answer, oops, is 20. Heavens to Troy, 23. I can add and subtract. So 27 minus 4 is 23. Let's do some algebraic expressions. In other words, they're just going to give me an expression. Now it's just plug and chug, where you take this number and plug it in both places that we have that variable. And so we're going to rewrite it. 1,080 divided by 30 minus the cube root of 1,080 divided by 5. All right, so we can do a couple things here in order. We can go 1,080 divided by 30, that is 36, minus the cube root of 1,080 and 5. Well, I know that 5 is not a perfect cube, so I can't really take the cube root of it. So this is one of those times, ladies and gentlemen, where before we actually take the cube root of each number, we're actually going to do the division. We're going to take 1,080 and we're going to divide it by 5. So 1,080 divided by 5 happens to be 216. Now I can take the cube root of 216, and I have 36 minus the cube root of 216 happens to be 6. And 36 minus 6 is 30. So this is a case where we did this math first. 1,080 divided by 5 gives us 5. So when you see that those numbers inside are not perfect cubes, then do the math first. However, if you did happen to take the cube root of 1,080 and the cube root of 5 and then divided those two numbers, you would find that the answer would be 6. I'll show you that in class. All right, ladies and gentlemen, let's do one more. We have the cube root of 8 times 64 plus 64. And so 8 times 64, well, I see that both of those numbers are perfect cubes. So this is taking the cube root of 2 times 4, which means that's the cube root of 8. And we're adding 64. And the cube root of 8 is 2. All right. Pretty straightforward there. Moving right along. Real life application. Find the surface area of a cube. I'm sorry, I messed up. Find the length. Find the length of a cube. The side length of a cube with a volume of 27 cubic feet. And we know to find the volume, we take area of the base times the height. We know it's a cube, so we know all those side lengths are the same. So this is going to be x times x for the base, and the height would also be x. So we know the volume is going to be x cubed. Well, we're putting in the number 27 is equal to x cubed. Well, ladies and gentlemen, when you have this, the inverse operation of cubing is to do what? That's right. Take the cube root. And if you do it to one side, you have to do it the other side. So the cube root of x cubed, well, that's going to equal x. And the cube root of 27, that's right. We already had an answer. That's 3. So our answer is 3 feet. Moving on to our last one, which says find the radius of a sphere. And we've done this. We've done this already. So we know that the volume of a sphere is 4 times pi times the radius cubed divided by 3, because it's 4/3 pi r cubed. But this is how we write it just to do the math. So we have the volume of 288 pi. That's equal to 4 times pi times the radius cubed divided by 3. We're going to multiply both sides of this equation by 3 to get rid of that 288. And that would give us 864 pi is equal to 4 pi times the radius cubed divided by 4 pi. We know that pi cancels out on both sides. 864 divided by 4 just happens to be 216. And we know when we're cubing a number, the inverse of that is to take the cube root of a number. And the cube root of r cubed is equal to r. And the cube root of 216, we did it a little while ago, is 6. And so the radius of this circle would be 6 inches. Straightforward. Last quick write. There are 3 parts to this quick write: D, E, and F. So you might want to pause or write it down as you're listening to me. Say the same thing I always tell you. Come to class tomorrow with questions on square roots and cube roots if you have them. Mark up your text. Mark up your notes, highlight your notes to ask me questions. Make sure you come to class asking questions. Always, always, always 45 minutes of quality effort, being accountable for what you're supposed to do, knowing that if you attack what you do, your assignments with some aggressiveness and urgency by using your time effectively, that you will learn more and you will remember it longer. Ladies and gentlemen, always a pleasure to be with you. Please come to class tomorrow with some questions. Can't wait. See you later.